Hello guys, so in continuation with my topic of logic gates part 3, today I'm going to discuss about the two important gates which is also known as exclusive OR gate. So let's discuss about these two gates, and we have discussed in our previous lecture also that what are gates, and in gates we have discussed we have six important gates: or nor, right? Or nor. Every time if you revise it, you know, not, and and NAND. Okay. Uh, so or nor, not, and NAND. So these are seven gates we have already discussed in part 1 and part 2. So let's continue with our another two important gates, which is XOR and X NOR. Now, what is XOR? Simply says XOR or X NOR. So as we did it in and NAND, so I think you can easily make out now to understand that X NOR is just the reverse of the function output table of XOR. So we say if our function table contains an output as the output as single variable as 0, suppose we'll get a function value as 0. That means if we reverse that value, that value becomes the value for XOR gate. So it is very easy to understand, just to reverse or make a bar, or you can say that if you simply put a bar on XOR gate, it becomes an XOR gate. Okay, so we can say a bar, a complement of XOR gate is my XOR gate. So one thing to understand. Now moving ahead, let's try and draw a table for XOR gate, and X NOR will be an assignment for you. I'll try and make you understand how X NOR works. Let's try and make the exclusive OR gate. Now, how does it work and where we use this gate? Basically, the exclusive OR gate is basically used in, suppose if we want to use the two input variables, how they're behaving. Seeing their pattern of output, we can make out what value of inputs we are having. I again repeat, seeing the output function, we can make out the behavior of whole function table, and we can make out what should be the inputs. मतलब I'll just explain it. अगर function table की कोई value में जो भी output आता है XOR की, उस output के basis पे हम उसके inputs बता सकते हैं. और जनरली XOR गेट हम लोग ये बताने के लिए भी यूज करते हैं कि क्या हमारे सिस्टम में कोई कैरी आया था या नहीं. अगर हम एडिशन ऑपरेशन परफॉर्म करते हैं, तो दिस इज वन एग्जांपल इन एडिशन ऑपरेशन दैट वी नीड टू से दैट yes, if my output is 0 or if my output is 1, so what will be my input? Depending on that, we can make out that yes, there was a carry or not. So this is one example of implementation part of an exclusive OR gate. Now, XOR gate table, if we talk about the XOR table, this gate is also known as exclusive, mark my spelling please, exclusive gate, okay, exclusive OR gate, okay. And another one, the opposite of this is exclusive NOR gate. So this is a full definition of exclusive OR gate. So XOR, in short, we can write it as. In some books also you'll find it. They write it exclusive OR gate, XOR gate. Okay. Now let's try and make an function table, a function table of XOR gate. Again, we'll take two variables, and I've already explained you what you have to remember, that how many combinations are possible depending on the total number of input variables. If suppose we are having n input variables, the possible combinations are 2 to the power n. Every time you have to remember this. And in my previous two videos also I emphasize on this part, because if you don't know how many variables you are taking, you are unable to make the combinations, you are unable to take the function table ahead. So we'll take two variable map of exclusive OR gate, and we try to take out the output. Now, how does this behave? Now, how does exclusive OR gate function looks like? Now, if you ever seen, हमने देखा था कि x plus y is an AND gate, x dot y is the OR gate. I apologize. I just repeat the reverse statement for this. This is my OR gate. This is my AND gate. Now, what is the symbol for exclusive OR gate? So, this would be a plus and a circle is a symbol for my exclusive OR gate. Another thing which you have to remember that the symbol for exclusive OR gate is making a plus sign and a circle is my exclusive OR gate. And if we talk about similarly the XNOR gate, if I am having a circle and inside there is a plus sign and have a complemented value, this becomes my XNOR gate. So we can simply make out the reverse of XOR, the function table, whatever output my function table of XOR will give me, right? Suppose function table gives me 0, 1, whatever it is. Let's try and find out. So the reverse of this will be my XNOR gate. Okay, now I hope you have understood this part. Now this is equals to, I again repeat, this is equals to, we define it as we define as, this is a logical multiplication. How do we perform here? So this is x bar y plus x y bar. In some books you'll find this is written as, I again write it, x bar y plus. I hope most of you are able, if they have studied the De Morgan's law, they can make out the things, but I don't want to confuse you right now. Okay, so this is the one way of writing it. Either you can use a dash here, x dash y plus x y dash. This is my now this is my supposed function. So this is my exclusive OR gate. Okay, I hope you are able to understand. The exclusive OR gate is either I can write in this way or I can write it. This is a symbol for exclusive OR gate. Okay, so if I write like this is my exclusive. Now let's try to prove this. What will be the output if I use this in my function table? And here also likewise I did it in my previous videos. I take two variables and we can generalize it to three variables as well, four variables as well. But in exams generally 2, 3, 4 variables, you might have make a k map. So we generally make 2 variable, 3 variable, 4 variable and so on. So we'll take two variables x and y. We know what output we want. So the output we want is, so let's start from here. Okay, we want an output of x exclusive y. Okay, and this will be my x bar plus, x bar y. I make it again. There is a problem with my handwriting. Try and improve it. Okay, let's start and make it what output we are looking for. We are looking for an output of x bar y plus x y bar. Okay, so and this we can say that this is equals to x exclusive y. Okay, now take it in reverse direction. We know we want a function table as x bar y. So we need, it's very obvious, that means we need x bar, we need y bar. You can make it this way also. Either you can take it as x bar, y bar together, or you can make it this way, that you can make x bar and you can here only you can do it x bar y. So we can do it anyway. but we'll try a standard way as it has been generally described in books, because you would be following the books as well. So let's try and find out. We need x bar, we need y bar, and we need x bar y. You can make out from this table. And can you make out this? X bar y, and this is an AND gate in between of these two. So x bar y plus x y, sorry, we have to make it's and try and make it separately first. We have identified x bar y bar, and now let's identify, make another column and make x y bar. Okay, so ये थोड़ा दूर हो गया, but it's not a problem anyway. Okay, so this is how x bar y and xy bar. We got this. Now see, now let's take two variables. We have two variables as the combinations possible. Two variable, four combinations are possible. 0 0, sorry, 0 1. So we have a possible combination as 0 1. Then we have 1 0, 1 0, and 1 1. Okay, now x bar. So simple x bar is the complement of x. So you can see here the complement of 0 is 1, 0 is 1, 1 is 0, 1 is 0. I again repeat how I get this column x bar. X bar, I highlight this, x bar is the complement of x. Okay, and my complement or NOT gate, this is also known as, we have discussed x, and x bar is my NOT gate. That means I do the reverse part. So I just found out the reverse of 0 is 1, the reverse of 0 is 1, for 1 0, for 1 0. Now let's try and find out for y, and if we found out the reverse for y, the value of 0 input will get 1, 1 0, 0 1, and 1 0. So we'll get a value of, you can make out that the value for y bar is the reverse of, I highlighted with the blue point. So you can see this is the reverse of y variable. Okay, so we simply says the complement, you can use the correct word as the complement. We have complement the value. So pathetic spelling I have written. Anyway, okay, so now then the next step says what we have to do. We have to calculate x bar y. Okay, we have to calculate x bar y. If you can see here, we have calculated x bar y bar. Now it is easier. We just try and break this whole function to make this function table. We want, and we know that the output function for an exclusive OR gate, x exclusive y, gives you x bar y plus x bar y bar. How we'll get this? We'll get this function as, if we calculate the value of x bar, we'll do an AND operation between x bar and y. Then we, this is my, yes, this is my AND operation. Okay, x bar y. So this is my AND operation between x bar and x bar y. So AND operation between x bar and y plus, this is an OR operation, x y bar. So we need to calculate the complement of x bar, y bar. We need to do the AND operation between x bar y and x y bar. And finally, we have to perform an OR operation. So you can make out very easily from this function table that this is my AND operation and this is my OR operation. Okay, so this is my OR operation. ये मैंने किया है. ये मेरा AND operation. Okay, between x bar and y. Now let's try to complete this table now. X bar Y we have to calculate. Now what columns we have to see now? Now it says and X, Y bar we have to calculate. So we have to look for the column X bar, which is my X bar, this is my X bar. Y, X bar and Y. So we have to perform, I highlighted with a red pen, okay. So the combination between this, which variable? X bar Y. So this is my X bar and this is my Y bar. I perform an AND operation between these two. So performing the AND operation between these two will give me, and we have learned this in my previous video also, I told you that the AND operation is a logical multiplication. So every time if you encounter a 0 in that, you always get a 0. So 0 1 0 will give you 0, 1 1 will give you 1, 0 0 will give you 0, 1 0 will give you 0. Now moving ahead, X Y bar. For this we have to, I'm highlighting it with blue, X Y bar. So we need a X column and a Y bar column, and we have to perform again an AND operation between these. We perform one operation between these two, then we perform operation between X and Y bar, and again we are using the AND operation. 0 1 will give you 0, 0 0 will give you 0. I hope I have checked the right column. Okay, and 1 1 will give you 1, and 1 0, see here, 1 0 will give you 0. So we have understood that if we encounter any variable as 0 in AND gate, the output is 0. So now these two columns are ready now. So we know that we have identified X bar Y, we have identified X Y bar. Now we have to calculate the whole function, and there is an OR operation between these two columns. So now we perform, I'll take another color, that is a black color, and we are performing an OR operation here. So I just say here we are performing an AND operation. Okay, so this is my AND operation, minded, and here we are performing an OR operation, which is a logical addition. Now, and we know logical addition says if any input is 1, we'll get an output as 1. If we have any single input as 1. So these two, both variables are 0. So we'll take a 0 here, 1 0, 0. This is a, I again repeat, I beg your pardon. 0 plus 0 gives you 0, 1 plus 0 will give you 1. So we'll get here 1 0 1 1 and 0 0 0. So this is my exclusive OR table. Exclusive OR table will give you this value. So now I just write, so this is my X Y. Okay, so this is the value for exclusive OR gate. Now see if you can make out the value for exclusive OR gate. Mind these values very seriously and try to identify. You can see we are getting the two outputs as 1 when we are having both the different inputs. I repeat, the important point to note in exclusive OR gate, if both the inputs are 1, that means both the input variables are different or must be different. If we are getting a 0 as output, the input variables must have been 0 or 1 1. That means I try to make you understand in another way also. Let's complete the table for NOR also. The reverse for this is my NOR gate. So I simply write in this table, there will be exercise for you. You have to calculate the value for this is exclusive whole power function. Okay, so we just make the reverse of it. We'll get the complement of 0 is 1, the complement of 1 is 0, the complement of 1 is 0, and the complement of 0 is 1. So we have again complemented here the value. So we have complement the value here in whole table. So this is my X NOR gate. So if we say this is my X NOR gate. Okay, the reverse of XOR. So you can find it out the table for XNOR gate. Now let me conclude this for XOR and XNOR gate. So concluding this, I'm just getting rid of this board here to explain you and conclude my exclusive OR part and exclusive NOR gate. So here we okay. So now see. So we have understood this thing in case of exclusive OR gate. When we are having both the inputs as 0, we'll get a 0, 1, 1, we'll get a 0. And if we are having the inputs as 0 and 1, and 1 and 0, we'll get 1, 1. What we can make out? So we can make out that if 0, 0, 1, 1, we can say if inputs are same, we have I'm trying to write a running writing. It's not possible for me to write that. Okay, let's try it again. If inputs are same, output is output is same. Okay, that means we can say output is 0. Sorry, I beg your pardon, is 0. And if inputs are different, then the output is 1. Okay, so if my output is 0, that means inputs must have been same. Or we can say it vice versa, in a way that if my output is 0, if we encounter a 0 output, if my output is 0, that means the input must have been same. तो या तो वो 0 0 रहे होंगे या वो 1 1 रहे होंगे. हम कह सकते हैं कि अगर हमारा आउटपुट 0 आएगा तो हम कहेंगे कि हमारा इनपुट सेम रहा होगा. अगर हमारा आउटपुट एक्सक्लूसिव OR गेट का 1 आएगा तो हम कहेंगे कि हमारे इनपुट्स जो हैं वो डिफरेंट रहे होंगे. या तो ये कॉम्बिनेशन रहा होगा 0 1 का या फिर 1 0 का और ये डिफरेंट रहे होंगे. ये हो गया हमारा exclusive OR gate. So I hope you have understood the difference between how we check, and this is very important part to note in case of exclusive OR gate. If we have 0 as output, the inputs same, and if we have 1 as output, the inputs must have been different. Now let's try and make the logic diagram for the same. So this is important part. Now quickly try and make the logic diagram for exclusive OR gate, and there will be an exercise for you all for XNOR. It's just the reverse of exclusive OR gate, or the function table works like I'll just tell you the XNOR function table works like X bar, okay, X exclusive Y, this is my exclusive OR gate, and if you just do the opposite of this, or the function table will work like XY bar, okay, प्लस एक्स वाई बार. ठीक है, एक्स वाई बार, एक्स वाई. So this is exclusive NOR gate function table output X NOR. Okay, or we can write it x y bar, x y का whole bar plus x y. So this is my x exclusive, y का whole bar is my x naught. This is x bar y plus x y bar. So you can see the difference between these two. The XOR, this is my XOR gate, so we can make out a difference between XOR and X NOR gate. The function table gives you the output as X bar Y plus XY bar, and for X NOR you will get an output as XY bar plus XY. So to calculate this, what you have to do, you have to take XY and perform an AND operation between XY and take a complement of that function, and you have to perform an AND operation between XY, and then you have to perform a uh, a these are two AND operations, and in these two operations you are performing an OR operation. This is X NOR operation, this is X OR operation. Now just to conclude, let's try and make the truth table. Sorry, we have already made this is also known as a truth table. We'll make the logic diagram the same. Now try and make the logic diagram. So this is how one way you have to use, just like you make your OR gate, and just correct it. It will not just like a D. This is how we'll make an exclusive OR gate. Okay, this is how you make a exclusive. Okay, so this is my exclusive OR gate. X exclusive Y. Okay, so this is my exclusive OR gate, and the another way you can make it, this AND gate, this AND gate. Okay, so we know that we need two variables X and Y. Okay, so we need X and Y, that means X bar Y. So actually the input from X is X bar Y. So how we make that? X and NOT gate. So we try and make this. Here is a NOT gate, and this is how we make. This is my X bar. Now this side is X. We have inputted an X variable, and we can see here that this is also the another way of making a logic circuit. We also say this as logic circuit. Okay, so this is one input and this is my Y. So X bar, so this AND gate is taking an input X bar and Y. Here we are making input as X and Y bar. So again we'll put a NOT gate here so that we can reverse its value, and we'll make a function as XY bar. And both these are connected with AND gate, which gives me an output as X bar Y. This is how we make the logic circuit also. Try and make different types of logic combinations. So if you want, you can write in comment section for X NOR gate if you want a on X NOR table also, but I think you would now be able to make your X NOR table, and in comment section you can also tell me how different logic circuits are being made. Okay, now these two are connected with a plus sign. We remember X bar Y plus XY bar. So that means plus means we are using the which gate? OR gate. So this is my OR gate. So this now X bar Y plus X Y bar. So okay, so now let's conclude these XOR and X NOR gate. Exclusive OR gate, the reverse of exclusive OR gate is X NOR gate. The function table output for XOR is X bar Y plus XY bar. The function table output for X NOR gate is XY whole bar plus XY. This is the function table for X NOR, XY whole bar plus XY. This is the logic circuit. This is these are the two ways in which you can make exclusive OR gate diagram. This is a block diagram, we can say. This is a logic circuit wherein we are trying to show each variable independently. Here we are taking NOT gate, then we have taken an AND gate, then we have taken an OR gate. So X bar Y, X bar Y, XY bar, and these two are connected with an OR gate, X bar Y plus XY bar. Okay, so this is this completes this, and we have understood that if exclusive OR gate, the important point to note for exclusive OR gate, if we get the output as 0. I again repeat, this is very important. When you study further, you have to make it out. If we get an output as 0, that means inputs are same. Okay, this is one conclusion we can make out. I'm so sorry. Inputs are same. Okay, and if we are having 1 as output, the inputs are different. This is a very important point of an exclusive OR gate. Okay, so that's all for this video. I hope you like this video. Please do mention. I have mentioned in description box the part 1 and part 2, and if you have anything related to this, you can put it in comment box, and what further topics you are interested in knowing in detail, so you can also mention in the comment box. Thank you so much.